I want to start, of course, with what is e-taxi. I suspect everybody here knows what e-taxi is. E-taxi by itself is moving the aircraft without using the engines or without using a tug. So in theory, at least, TaxiBot would fall outside, but WheelTug or Safran Honeywell's work would count as e-taxi. And what we do essentially is show the difference in the wheel. Our wheel is shown there on the left. We had a clip last month on CNBC, which was broadcast worldwide. And the clip on the left shows the WheelTug system built into the nose wheel. And the clip on the right shows the standard 737 next gen wheel. So the A320 would look much the same as this. I'm just going to be jumping back and forth to videos because that's how it works sometimes. Sometimes it's easier to show. If you don't know what e-taxi is, sometimes it's easier to look at it. As I say, watch the birdie. Aircraft traditionally do not roll backward by themselves, and if they do, you have a real problem. But in this case, of course, the aircraft is driving backward by itself. The engines are covered. And this would be a gate maneuver kind of operation. You drive the aircraft backward, and then you can drive it forward. Simple enough, rare, and valuable in some interesting ways. For starters, if you look at how the system is connected here, I'm going to pause it right there. You can see that, maybe I'll use my mouse, that might work better. You can see that there's a little mechanical connection here. That is the linkage for the torque to the tow bar, and that's how we connect the motor mechanically. There's also an electrical connection on the other side. And the system fits entirely inside the wheel. The other benefit, and I'm going to talk about this a lot, has to do with how you turn the aircraft and operate it at the gate. Because there are things about e-taxi that are not obvious. In this case, of course, you can drive the aircraft around, turn it on essentially on one axis. If anybody's taking the time to video, I can let you know that we have a professional video crew and it will be on YouTube. So it may be a delay of a little bit, but you don't have to worry too much about videotaping. Okay, so turning the aircraft is good. And that's the end of this. That is, if I can get my computer to cooperate. There it goes. Right. So the system is designed to be as simple as possible. What we have here are electric motors built into the wheel. We keep the existing tire. We keep the existing axle. We keep all of the same long lead time forged components. So the piston and the axle remain the same. Here is the electrical linkage coming up. Again, this is a prototype for demonstration and for certain calibration purposes. We have electronics here that control the ATRUs, take the APU power, rectify it, and then turn it into high phase order motor. So this is an induction motor technology, which means that if it's not powered, it's inert. These sit in the avionics bay. And then there's a cockpit panel, as you can see on the top right, that allows the pilot to control the system. It is essentially driven much like a golf cart, forward and backward. That's all it does. It goes backward, it goes forward, and so on. It's designed to be very simple. It's designed to be installed in no time longer than an overnight out of service, which is very important because it also means that it can be uninstalled. And this is a design requirement for us. This system is a temporary system. We want airlines to think of it like an electronic flight bag, like an iPad in the cockpit. You can put it in, or you could take it out. For lessors, this is extremely important because lessors want the airplane back the way that they gave it. And so the less number of legal hurdles you can come up with for installing the system, the better your market adoption. So I've covered the rapid retrofit and the uninstallation. It is powered from the APU, and it is, again, a stupid system. We're not talking to the airplane. We're recording our own data, but we're not feeding data into the aircraft. Also, very importantly, the system does not have to be functional for the aircraft to dispatch. The airline nightmare is AOG, aircraft on ground. So they don't want any systems that have to be functional in order for the aircraft to fly. So there are certain systems that can cause an AOG. In the case of the 737, for example, if the coffee machine is not functioning, the aircraft cannot fly. The A320 pilots apparently have different caffeine requirements, and the coffee machine, it's okay if it doesn't work. I'm not joking. That's the truth. In terms of maintenance, there's no maintenance item that's more regular than the tire changes themselves. And of course, tires, when the tires change, the wheels are inspected anyway. So we've demonstrated in their videos on our webpage, we've demonstrated the system operating here in snow. We've operated it on ice, slips, but it works. Demonstrated it here in Prague on water. This is an external wheel system, and this is the internal wheel system, as you can see in our development path. Again, it's designed to be as simple as possible. It's designed to be so simple that our team, which includes Parker Aerospace, which includes the chief design engineer for the A350 landing gear and the 787 landing gear, that our team are capable of doing the integration work ourselves. So there's no requirement for the OEM to take that on. This is not something that requires a big investment. It requires merely data. And what makes the simple system more EFB-like is that the way we operate the system and offer the system is that we give it to the airlines free. We give them the system free, we install it for free, we train them initial training for free, we also pay for all replacement parts and all upgrades. That's on us, in return for 50% of the savings. That's the model. And it's very, very simple indeed. You're offering the airline something that can save them money from the moment the system goes on the aircraft, and they can take it off after. Also, there is no long-term commitment. WheelTug takes the risk on this system. We have to make it work. No matter what, if you offer something to an airline and it doesn't work, you're going to end up holding the bag, one way or another. You have to make it work yourself. So the systems are designed to be removable, and that's very important. All right, so how do we get here, and what are the ways in which one designs such a system? Now, traditionally, of course, in aerospace, you start a project, and what do? You start by defining your requirements. What does the system need to do? Well, you get a bunch of engineers, they say, okay, we're taxiing the aircraft, that's very nice. Where do you go? Who do you ask? Typically, you ask the customers. You go to the airline, and you say, what do you want your e-taxi system to do? And that airline, that will tell you, well, let's look at what it does and what it can gain us. And what can it gain? The obvious benefit of e-taxi is very simple and very deceptive. The obvious benefit of e-taxi is using the motor and keeping the engines off. So your benefit is fuel savings. Everybody knows that e-taxi is all about fuel savings. And so you go off and you design a system that is about fuel savings. And that means that it has to do a number of different things. It has to have a top speed, so you don't slow down the traffic on the tarmac. It has to have the acceleration to match, perhaps even, the acceleration from jet engines on the ground. A bit of a tall order. You want it to work all the time, so it has to have excellent traction. That's how you start with your requirements. So you go off and you design something. The only problem with going off and designing something is that e-taxi is not actually a normal system. It's not a normal technology. There's something called a disruptive technology, and a disruptive technology does things you don't expect. It has savings and benefits that you don't expect. And if you don't think about all of those and work on them for a long time, you can end up designing the wrong product because you haven't thought through what are the real benefits of electric taxi. And what e-taxi does is it allows you to do things that haven't been done before or haven't been done in a very long time. So I'm going to show you, well, maybe it's a little later on. I haven't been done before. We spent a lot of time, we've been working on this for 10 years. We spent a lot of time looking at all the savings opportunities We're talking to 300 airlines worldwide, and determine the real value of e-taxi. Well, start off with fuel. That's the one everybody knows about. How much is fuel actually worth? The reason why people say they want fuel savings is because fuel equals money. So what they're really saying is we want to save money, but we'll call it fuel. It sounds better. What are the savings from fuel? About $12 a taxi minute. That's the delta between using the engines and using the APU, right? So the APU is 4 pounds a minute. The engines, depending, single engine, dual engine, 17 to 25 pounds per minute. So there's your $12 per taxi minute savings from fuel. You also have a benefit from engine use. If you look at that map over there, you see all those red dots. Those red dots do not tell you the percentage of sand and dust and rivets and soda cans that exist at 30,000 feet. Those red dots tell you where engines have distress based on ground conditions. Because it turns out that running the engine on the ground is actually very unhealthy for engines, as lessors can tell you in great detail. We have one example in the Persian Gulf shown here. An engine rated for 39,000 hours is getting 13,000 hours before overhaul. Engines traditionally cost about half as much as the airplane. So you're talking about a tremendous hit on the value of the aircraft because you run the engines on the ground ingesting dust and debris. In the case of the Middle East, of course, sand. So the engine cost is real, but nobody cares about engine cost because nobody looks at it. People look at fuel savings. We know we can save fuel, but nobody thinks, what does this do for engine maintenance? What does it mean for engine maintenance? Savings here, conservatively, are maybe $1.50 per taxi minute. It's not a big number, but it's a number. There's also a performance retention number. If you see that yellow line over there on the graph, it shows you how, the black line, shows you how an engine approximately degrades over time. New engines are more efficient than old engines. Why? Because the old engines have taken a lot of damage, and that a percentage of that damage, according to Rolls, 80% of that damage comes from taxi damage. So there's another benefit here by keeping the engines off on the ground, because you can move the black line toward the gold line. That's fine. Again, e-taxi can unlock this value, but everybody's thinking fuel savings. And of course, there's pushback. Pushback costs, pushback shouldn't be a very expensive thing. You have a tractor, you have a guy who drives the tractor, and you push the airplane back a few hundred feet. And it shouldn't cost a lot. But I can tell you that in the United States, it costs $50 to $100. In Europe, it's easily €100, sometimes more. In Asia, it can cost as much as €500. That's what the Asian airlines tell us. They're much less efficient with aircraft movement. That's a lot of money. Compare that to the fuel at $12 a minute, and you see that pushback could be a very big deal indeed. But what really makes pushback expensive is when things go wrong. For example, in this top row here, the tug drives into the engine. It has no business driving into the engine, and it does anyway. Very expensive. In this case, this aircraft was towed into a tug. They pulled the tug off, the engine went down by 8 inches. Incredible damage. In this case, you see the tug is flipped 180 degrees. It's a lift tug. It went around, it was icy conditions. It ripped the gear 180 degrees on the airplane. I gave a presentation to an airline. I said, look, all of these happen only once. Accidents in aviation do not repeat. A man in the room looked at me. He said, you're fooling. He says, I was the ground operator at that airport that winter. That very same accident happened 3 times. Very expensive on an A330. You have tugs that oversteer, rip the tow bar fitting. You have drivers who think for some reason they can get under the airplane, right? Ow. Twice. Another engine attack. You have this one, the lady driver, she lived, but she ripped the airplane apart so much that that aircraft is now used for fire training. It never flew after this accident. Very expensive. And you get this brilliant one. I was giving a presentation and the guy says, I was on that airplane. The tow driver connected the tow bar to the airplane, got behind the wheel, drove. and hadn't checked to see whether the tow bar was connected to the tug. And he took out the nose cone of that airplane, which also never flew again. And most traditionally, this is the most common form of accident, this one here in the bottom right. You get the case of the maintenance tow. Maintenance guys are the best because nobody's paying attention. They can do what they like. The maintenance guy gets behind the wheel of the tug, starts pushing the airplane, and the airplane doesn't move. I said it was a man, right? So what does he do? He pushes harder. He didn't check the brakes. The brakes were set. Collapses the nose gear. This actually happens a lot, and it's expensive every time it does. So those costs get folded back into, one way or another, it's a pushback cost. One way or another, the airline will absorb every one of these costs. Now, people often ask about weight. Weight is a demerit, right? Carrying weight around on the aircraft is a bad thing. Everybody knows more weight is more of a bad thing. What is the actual cost of weight? Well, on a narrow-body operator, or any operator, there is a tankering rule. And this is a really good way to find out what weight costs on an airplane, because airlines make this calculation every day. If it's cheaper to buy fuel here than there, how much does it cost me to fly extra fuel and not fuel up when I get there? That's the tankering rule. And the tankering rule, at 4 pounds per 100 pounds carried per hour, tells you that a cost of a 300-pound system is about $12 a flight. Okay? So there's our big negative cost, $12. But there are other savings that can be had. And this is, again, where not thinking about it can lead you to the wrong conclusion. We know from operations in Denver using an A320, lots of them, with over-the-wing gates, savings of 12.5 minutes every single turn. Now, these over-wing gates are pretty ugly, and they sometimes hit the airplane, which also makes them unacceptable. But the savings could be very large, especially because time is being valued. Two-door operations, of course, are common with EasyJet, perhaps with Ryanair. Low-cost carriers use two-door operations because they know that time is valuable. EasyJet turns an aircraft in 25 minutes. Does anybody know the shortest time that Lufthansa can turn an airplane in their own published numbers? I guess. 40 minutes. The average is closer to 65 minutes. Time is valuable, and it's one of the biggest things that low-cost carriers do to beat up the legacy carriers. They turn the aircraft faster. The problem, though, with using the back door for stairs is that it's not reliable. You don't know if it's going to rain. You don't know if it's going to snow. You don't know how hot it's going to be. And so you can't book that advantage into your schedule. You can't bake it in. You can't say, I know my turnaround is going to be this time. The only advantage of a rear door stair, in this case, is to eliminate delays that happen later. So I want to show you a new video we haven't released yet publicly. It just takes a few minutes. Jet blast is very, very important in e-taxi. I'm going to stop it for just a second and point out that one of the other advantages of this two-door operation is that today the nose jetway includes power and air conditioning for the cabin. And that eliminates two vehicles that would have to be there otherwise. In the tail, if you have a jetway here, then you have the ability to also eliminate two more vehicles at a minimum, the wastewater supply and the freshwater supply. And if you do something under the belly of the airplane, then you could have the baggage come as a conveyor underneath the jetway back to the terminal. You can eliminate many more vehicles and perhaps other benefits. Note that in this case, once the tower gives clearance to push, you don't have to wait for a ground marshal. The pilot can drive straight out. That's a big source of delays. Now there's something else we call the twirl. So to compare a pushback with a tug to the twirl, and there you have it. That's the real value. $12 a minute, we're talking about $1,000 a flight from driving using electric motors. That's the value of e-taxi. So, in terms of time savings, the twist gives us 12.5 minutes extra savings. These are hard numbers. Hundreds of flights were done, at least. Waiting for pushback, we get a benefit from both the twirl and the twist. We end up with a total of almost 17 minutes for the twist at a minimum and 4+ minutes for the twirl savings per minute. All right, well that's nice, you're saving time. Is it worth anything? Can you prove that it's worth anything? The answer is, well, of course you can in a sense, because we know that airlines that fly more flights per day, that utilize their aircraft at a higher rate, make more money. The airlines that don't fly the airplanes very much lose more money. And so we know that utilizing that, freeing up time, if you can bake it into the schedule and know that you're going to save 15 or 20 minutes every single flight, you're able to adjust your schedules and get more operations of that aircraft. That's $30 per minute. I would note that in a hub operation, this is harder to figure out because hubs have a different way of operating. But point-to-point operations, this is much clearer to show. But fare impact is also a very interesting part, and there's a fascinating study that show what passengers will pay for a ticket that gets them there faster. And this is a very important thing because the assumption is the passengers always buy the cheapest ticket. But of course we know that isn't true because there are a lot of people who fly business class or first class. And we also know, thanks to the study that happened at LaGuardia, that passengers will pay to avoid an airline that they know doesn't get them there on time. Now, the bargain passenger won't pay. The Ryanair passenger won't pay. But the Lufthansa passenger who wants to be on the first flight from Frankfurt to London absolutely will, consistently. The FAA number assumption is about 77 or 75 cents per minute per passenger. This number, by the way, is only for coach class. The analysis for business class or first class passengers is a multiple of this by about 10. So 77 cents per minute per passenger. Passengers historically will select flights that do not have delays, that do not historically have delays, and they will pay more for them. And if they pay more for them, that shows you that there's time value to the airline. That's why airlines care about on-time arrivals and departures. That's why they advertise being on time. Because if you absolutely must be there, if you're giving a presentation at the Royal Aeronautical Society, you check to see, is my flight going to get there or not? And if it's not, you pay more for a flight that will. That's $85 per minute saved. So look at the value of e-taxi by operation. We're talking about the taxi value, which everybody thought was the big number, of $18 per minute. The time saved is $115 per minute, and pushback is $100 per cycle. But let's do it by capabilities. The twist then is worth $1,800 a flight. The twirl might be worth $500 a flight. Pushback remains that fixed $100 number. But then you have the other requirements. You have the high-speed taxi and you have low-speed taxi. Now, high-speed taxi is running out to the runway as fast as you can. A lot of people don't appreciate that you don't actually have situations where you do high-speed taxi for very long. Why? Because if you go 30 miles an hour, you get to the runway pretty quickly. And you need 3 minutes to warm up your engines minimum anyway. So high-speed taxi can be a big confusion. Low-speed taxi, on the other hand, is what happens at the gate, and it's also what happens when there are unexpected delays, when you're in stop-and-go traffic. If you assume a line of A320s all in a row, waiting to take off, at Heathrow, where they take them off one every 60 seconds, then your average speed is somewhere between 3 and 5 miles per hour. That's the actual low-speed taxi delay case. Let's go back to the requirements and see what we've done. In order to do high-speed acceleration and stamina, assume that you can accelerate the airplane with electric motors just like you can with an engine. Then you need that for high-speed taxi. That's required. If you need high-speed acceleration and stamina, these are the requirements. It benefits high-speed taxi. Now, I need to point out on stamina that there's something else that's not widely understood and should be widely understood. L3 Crane were working on a competitor to WheelTug in the main gear. And they ended up abandoning the project for business case reasons. But that competitor they built had liquid cooling to the motor. Why? Because they ran the numbers and realized that if you're going to drive the airplane for any distance at all, you're going to get too hot. And electric motors do not like heat. Electric motors fail at elevated temperatures. You're dumping a lot of power into an electric motor, and you have a stamina problem no matter what. No e-taxi solution that is uncooled is going to drive 5 or 10 miles at high speed. It's not going to happen. It's too much heat. We are asked about A320 turning and traction. First of all, I point out on the traction side, this is eliminating the whole nose versus main question. But obviously, if there's twice as much weight on half the surface area, then the traction patch remains the same. So that's a constant. We also found that the breakaway torque does not require 2 wheels because we've operated aircraft with only 1 wheel operating at a high rate of turn. Because when you brake the aircraft when you turn at a high rate, you actually only end up moving one of the main wheel bogies very far at a time. And so you actually get breakaway with much force. But most importantly, and I need to stress this, if you ask our competition, why are you not in the nose gear, they will tell you it won't work 100% of the time. And they're absolutely right. We will not operate 100% of the time. We will only operate approximately 95% of the time. Because if it's cold and wet or icy or snowy or the CG is very far back and a bunch of other things have been put together, then the nose wheel will not have sufficient traction to move the airplane. That's a fact. That's a reality. But what does it cost to go from 100% traction? If we only work 19 out of 20 times, then we only save 19 out of 20 savings, which means that actually we come out looking pretty good. This assumes, of course, that airlines quickly learn what those bad cases will be, and they certainly will. They'll know that in certain conditions, in certain cases, the aircraft won't dispatch. So why do we use the nose landing gear if it won't get us 100%? I want to talk about brakes. I'm not actually all that interested in the wear rate number, although it's interesting in itself. But what's very interesting here is that there's a brake hot warning light. This is on the A320. That brake hot warning light, and you see that there's two thermal lines there. One is the disk temperature and one is the indicated temperature, and they're different numbers. But you have to be very careful about brake temperature, because when the brake temperature gets too hot, the temperature of the hydraulic fluid is too warm, and the aircraft is not safe to dispatch. That brake hot warning, you cannot begin taxi out unless that light is off. That's an Airbus requirement. Now, assuming you don't have a fan, look at what happens during the day. You'd think, oh, you fly and it all cools off and you take off. That's not how it works. Brakes retain energy very nicely. And you can see here, the first flight of the day, you start off nice and cold. Look at the peak that you get there in real temperature versus the indicated temperature. Taxi in, it cools a little bit. And you get, again, a peak, a taxi out, but it builds through the day. Notice anything else about this slide? EasyJet, Ryanair, Southwest are sometimes flying 10 or more flights per day. This assumes 4 flights per day. What happens when you keep adding flights? What happens is that the temperature keeps going up. And you have cases, and you can Google it on the internet, of pilots leaving their nose gear down to cool them in flight. That is not very fuel savings efficient, in addition to having all sorts of other bad things with them. So this is according to an Airbus document. If that light is on, you can't dispatch. You can't taxi out. You can't take off. And very importantly, as it says here, in the case of rejected takeoff, that is the case. You have to know that your brakes can do an RTO before you start rolling down that runway. And according to Airbus, this is a delay and it's a problem. And according to the pilots who fly the aircraft, it's also a problem. No matter what, if the brakes are hot, then you can't dispatch. Well, what happens if you take a system that dumps kilowatts of heat and you stick them in with the brakes? What have you done? You have a massive heat source here. By the way, these don't have fans included. Probably they wouldn't have airflow anyway today. You stick a system in there, and you're expecting to pull out at least as much heat as you pull out today. Plus, you have another heat source that's going to be heating up the whole time, taxiing in and taxiing out. That is the problem. If you're adding the amount of energy that has to be dissipated from the same area, and you already have a system that has limited capability by thermal cooling, adding another heat source is not healthy. It's not healthy for the brakes, and it's certainly not healthy for the motor either, because, as I said before, motors don't like heat. If you start your taxi with a hot motor, your stamina goes through the floor. Now, it's possible that you could re-engineer the fans and have a super fan cooling solution, you know, the little turbine that's sitting there, sucking the air. But that does have complications as well. Already today, pilots are not allowed to use brake fans on takeoff and landing. And the reason they're not allowed to use brake fans is because of FOD damage, foreign object debris. Sand damage to the brakes comes in, it's a problem. If you have high-speed fans and you put that in a desert environment, you're going to end up with a choked system. A system that isn't providing cooling at all. That's the problem on the cooling side. And that's what makes the difference here when we talk about the twist and the twirl. You have to be able to cool the airplane. You have to be able to cool the brakes as quickly as you can in order to unlock those savings. If you put something in the way of that cooling, then you don't get the advantage of turnaround time. You can't use a main gear system. And if you look around the internet, you'll see over just in the last month, there are dozens of stories talking about how airports are reducing ground taxi times. JFK is doing it, Cesar is doing it, other airports are doing it. Everybody realizes that you might as well sit at the gate instead of sitting out on the runway. Everybody's trying to reduce ground times. If you reduce ground times, then you need to cool the brakes even faster. And that's a big deal. You probably don't need the unimpeded brake cooling for low-speed or high-speed taxi, but it really depends on the case, so I left that as a probably. So let's look at this on the value of requirements per flight. Unimpeded brake cooling, the twist and the twirl, gives us $500 to $1,800 every single flight. Pushback, assume we're only 95% of the time, that's $95. Low-speed taxi, assume we're operating 95% of the time. Again, those are those numbers. What is the difference between 100% traction, 95% for pushback on top of that? $20 a flight. It turns out that the 100% case is an engineering requirement, but a commercial loser. Looking at value of requirements per year, per aircraft, we're talking about the twist and the twirl able to unlock $750,000 to $3 million per airplane per year. That's more than it costs to lease an A320, a new one. You've got pushback benefits, low-speed taxi, high-speed taxi, those numbers are real. Again, the 100% to 95% number is very small by comparison. So when you compare a nose gear solution to a main gear solution, the brake cooling ends up being the most important thing. You think, oh, it's fuel savings. It's not fuel savings. It's time savings. The main gear solution is superior for traction, and you end up with a benefit to the main gear solution that WheelTug cannot match of $34,000, and the other way around, something that is $750,000 to $3 million per aircraft per year. Plus, of course, our business case. This is a no-risk lease. We give the systems to the airlines at no charge, at no capital expenditure, at no commitment. Well, the airlines like it. We have 11 airlines signed up so far. I have another announcement pending, maybe 2, in the next week, with 2 more airlines worldwide. 1 737 operator, 1 A320 operator. Of those 11 airlines, 6 are flag carriers. None of them, interestingly enough, unless you count Air Berlin, are actually low-cost carriers. This is seen as something that legacy carriers especially benefit from. It takes years, if you ask anybody who works with airlines, it takes years to sell airlines a new system. We are talking to 300 airlines worldwide right now. And we have spent years talking to them. And that's how we have this client base that is climbing rapidly. Last week we won, that's my big smile there. Last week we won the Eco Award from ATW as the most environmental, the Eco Technology of the Year. It's very nice, the Wings trophy. We have the support of former heads of leasing companies, former heads of airlines, most prominently Bob Crandall, former head of American Airlines. For the students in the room who may not know who Bob Crandall is, he's the guy who invented frequent flyer miles. If you talk about the legends in, no, he claims it. If you look on Wikipedia, it's there. What was that?
Invented by part of Air France, which is called Air Inter. Sorry.
That's good. You come to France and you learn the French did many more things than you knew. And Bob Crandall, he's a living legend. There are basically 3 living legends left in commercial aviation. There's Herb Kelleher, Gordon Bethune, and Bob Crandall, and he's a pretty influential fellow. So we are working, of course, to talk to airframers, because airframer support can make a difference. We will be doing the integration work, but it can be expedited. Why would an airframer want to support e-taxi, or WheelTug specifically? Well, the first reason, of course, is that customers want it. And customers are actually what drive the industry. Airbus and Boeing may make all the money. Airlines may not make the money. But if the airlines don't sign up for an aircraft, it doesn't get built. The airlines end up wagging the dog. They are the ones taking the risk anytime somebody invents a new airplane. And of course, Airbus policy is to always support multiple suppliers. So Airbus should be supporting this technology as well on that basis. Now, take it from the airline or the lessor perspective. Why would you choose one aircraft or another? You've got 2 airplanes. They look about the same. They operate about the same. Each airframer can argue that theirs is 10% better, but sales are more or less running equal. Except that one of them offers you a savings, net to you, of over $500,000 per year. Let's put that in perspective. The fuel savings start down here. Pushback gets you there. Engine wear gets you kind of here. And then when you start talking about time benefits, it goes through the roof. What is this line here? This line is the net asset benefit to the airline each year from having a Neo or MAX new engined aircraft. Why are airlines signing with WheelTug? Airlines are signing with WheelTug because this technology can give them a multiple of savings over buying a whole new airplane. Buying a new airplane is a big deal. Buying a new airplane can be an airline killer if you do it wrong, or an airline maker if you do it right. But WheelTug isn't even for sale. So who do you choose? Well, we've been working at this a long time. We continue to work at this. We continue to hone and figure out what the savings from e-taxi are, and I guarantee you that there are many savings we haven't thought of, and there are many things we haven't done. Disruptive technologies do that. Disruptive technologies are hard to predict. But we've been working on it for almost 10 years now. And what we offer the airlines is a complete e-taxi system. We offer it to them free. We offer the installation free. There is no investment to the airline because it's a simpler system. It's a system that they can give back. We don't lock in commitments. We don't promise a 4-year or a 3-year or 2-year payback. It's payback from day one. And that's very attractive in return for half the savings. That's our model. It's a pretty simple model. The airlines can make a lot of money on it. And it's removable. If at any time the airline changes their mind, off the system goes at our cost and we'll put it on somebody else's aircraft. It's very, very hard to sell an airline on a permanent change. It's much easier to sell an airline an EFB because an EFB can go in the cockpit and can come out of the cockpit. So in an airline's earnings before tax basis, the last 3 years, 10 largest US passenger airlines made about $2 a passenger. This is a very thin margin business. WheelTug would add $3.50 to that benefit, to that bottom line. That's what it comes down to. And that's, I think, time for questions. Thank you. Yes?
How do you calculate the value that you charge the airline?
We have a spreadsheet that goes through these savings items, and we work. This is very important. This is why we lease instead of sell. We are working with a number of air navigation services, ground navigation services, airports around the world, and we have to work to maximize the return. How do we do that? We have to get the airport to agree, for example, to use the twist or the twirl, because we're changing the procedures. So it is in our interest to help the airline unlock the value. And so we have to work on an ongoing basis to make that possible. Day one, they're not going to be able to do the twist. They probably should be able to do the twirl. But if we work with the the airline and with the airport, then we open that possibility up. And so that's one of the things that's important from the airline perspective. We tell them, look, we're only getting paid when you save money. So we as a company have to work with everybody to make sure that you're making money as much as possible. And so we then sit down with the airline. Leases will start cheap, and then they will grow in value as the system proves its value. And there's certainly plenty of data to show you a turnaround time today, a turnaround time in 6 months, what that's worth to the bottom line. And of course, it's negotiated. So this is something, you know, every airline gets a special deal because that's how the industry works. Yes?
2 questions. One, you say the deal is that you'll give it to them free of charge in return for 50% of the accumulated differential profits from using WheelTug.
Basically, yes.
How do you monitor that extra profit that the airline claims it makes or doesn't make?
So the system itself records everything it's done. And we have the data from before operations, and we'll have data from after operations. And we will haggle. It will be a haggle. But the question will be, and I guarantee you, there will be leased airlines who will take WheelTug and change their mind because our price is too high, and they will decide to go without. Because that's how you find a price. You find a price by having a certain number of customers change their mind. And that allows you to keep adjusting the price and the value over time.
and then the competitive situation will determine further.
If there is a competitive situation.
Well, some airlines with it, some without.
Oh yes, absolutely. So the with and without WheelTug situation will determine it very much.
Second thing, question was, when it comes to the airports themselves, the commercial side of it, they provide facilities for the aircraft, including the tugs and the tug crew, etc., I presume. So removing all that lot removes, the airlines will pay for those services, and I suspect there's an element of profit in there for the airport. What about the airport economics on this?
So the airport economics are to improve the throughput of the, let me just get this right here. The goal for the airport is to improve throughput without compromising safety. And here's a picture of the twist before the twist was the twist. In the 60s, they did this with aircraft. They parked them parallel, and they used two-door operation. It's a benefit. It works. Getting the passengers off. If you ask a passenger, and this is, Air Berlin gives chocolates. When you leave the airplane, they give you a chocolate on your way out. Why? Because it finds out in studies that passengers don't remember the middle of the flight. They don't remember a 5-minute delay in the middle of cruise. But they remember a 5-minute delay getting off the airplane. The 757-300, the stretch, I don't know if you're familiar with it. The 757-300 is a beautiful airplane. On a cost per seat mile basis, it is perhaps a phenomenally beautiful airplane. And it only sold something like 55 units. The 757 as a whole sold over 1,000. Why did it only sell 55 units? Because it had up to 289 seats and one door. And people said that climbing on and off that airplane to the back of the airplane was the slowest yet most sure form of suicide on planet Earth. They hate it. But if you have two-door operation for an aircraft that's getting more and more passengers, well, the A321neo with the Recaro seats is going to have 236 passengers, at least, out of one door. That's not much more fun. If the passengers think getting on and off the airplane is fun and easy, they think the flight's a lot nicer, and you get a lot more passenger satisfaction. But if you look at these airports, you look at what they've done, San Francisco before, San Francisco now. You could make these twist airports. Cologne, right? You can see that making this sort of arrangement is absolutely doable. But you need to work with the airports. In your case, you bring the example of tugs. Airports sometimes provide tug services. In many other parts of the world, there are multiple suppliers of tug services. And it really depends on the airport and their unique situation. We're not necessarily eliminating tugs, but we are certainly cutting down their use on narrow bodies in a very big way. But the thing the airports love is the ability to get more aircraft moving. You look at this picture here, Atlanta Airport, this is a modern airport, lots of room, right? One of these aircraft backs up, and because of ingestion and jet blast risk, none of the other aircraft are allowed to move at that time. So we give out an executive level gift. If anybody in this room is particularly important, I'll give you one of them. I'm sorry, that was supposed to be funny. When they close the aircraft door, they say you have to turn off your electronics. And so we have this lovely mechanical stopwatch. We say, okay, I want you to record how much time is used between the aircraft door closing and when the airplane actually starts to move. We can save some of that time. The same thing is true when the aircraft finishes backing up, stops, disconnects before it rolls forward again. Record that as well. Another minute and a half, 2 minutes usually. Sometimes as much as 3. In this case, with the WheelTug case, you get much more throughput at the gate. You get higher gate utilization with less airport infrastructure. Airports like that. They also very much like the fact that it's an eco-technology. Why does aerospace have a bad reputation? Because we take people who can afford airplane tickets, we put them in front of plate glass windows for hours while they wait for their flight because it's delayed or whatever, and they watch pollution all day long. Tugs start up, engines start up, pollution. It's like putting somebody outside an interchange at a highway to watch pollution. If you clean up the gate area by keeping the engines off there, by eliminating the tug, then you can do a lot for the perceptions of the industry. When we did our study in Prague, we did a demonstration. The head of the Prague airport called me into his office the next day, and he said, Isaiah, he said, we were on primetime television last night for 3 minutes talking about WheelTug across the country. I cannot remember the last time there was a positive news story about our airport in the press. Positive news stories are a good thing. Eco-technologies are a good thing. Higher throughput without compromising safety is also a very good thing. And in this case, look at Heathrow. One of these aircraft backs up, it's an extra 2 to 3 minutes before it rolls forward. It blocks the ramp for everybody else coming or going. It's a nightmare, but it's not going anywhere. These terminals will be operating for as long as you and I, if not much longer. Atlanta's same way. If you eliminate blockage, if you get more throughput, you get airports on side. We're actually speaking, I think, at 3 or 4 airport conferences between now and the end of the year at their invitation, because they look at this and they say, there's a green technology. Where's the downside? You had a question? Yes?
I was wondering when the airport is backing up and there's possibly no rear mirror, how does the pilot actually know that he's not running?
Excellent. So the way we're doing pushback, if you're doing the twist, 1 second. If you're doing the twist where you're only driving forward the whole time, then the number of ground people is minimized and perhaps 0. At Schiphol Airport today, pushbacks are only 1 person. At other airports, there are 3 or 4 or more people, depending on the airport procedure. But Schiphol is certainly the most efficient in this respect. The goal is you have to see behind the airplane and the wingtips. Now, we are planning on including cameras with the system as part of the lease. They'll be under the just aft of the nose gear and able to see both wingtips and the tail. So the pilot will have enhanced situational awareness. It could also be a radar complemented system. But power pushback procedures are known and approved. There's nothing new here. You have a guy at the nose, you have a guy at a wingtip, they can see all the perimeters and they can approve with the pilot. Nobody talks to the pilot in this situation. It is just done visually. Again, for time-based reasons. Yes?
But you still require somebody to pull out the track of the...
For the chocks? Yes. No, we're not eliminating ground service. The airplane still needs to do everything it does on the ground. But yes, we are... If you spend time, and I'm sorry, I'm one of those sad people who does this. If you sit in an airport and you watch gate operations, and you see the pilots ready to go, the doors are retracted, and then you watch the people on the ground as they race to the wingtip to make sure that they're watching, they're not racing. They're going slowly as they can. Nobody's in a hurry. Even the low-cost carriers try to get people to move faster. Anything you can do to eliminate variables, it's going to make operations safer and faster. And so when we're talking about reducing the number of people for pushback in the twirl case, perhaps eliminating them in the twist case, depending on the airport, depending on the gate. Other question? Yes.
Yes, thank you for all these explanations about the savings for e-taxi and the eco profitability. I would like to come back on the differentiator for the WheelTug solution compared to the Safran Honeywell or Crane Airfree, whoever. I heard, maybe other people heard, that there may be an issue with the loads on the landing gear just because of the weight of the aircraft, not only when the brakes are applied on the main gear, but so how did you talk with...
So modifying a landing gear is, of course, a very important part of anytime you change something. If you want to compare, yes, we are changing the nose gear. So, for example, we'll have to examine uplock mechanisms. We'll have to probably enhance some of the pins or connector pieces. We will definitely have to do shimmy analysis and have different shimmy dampers in order to ensure that safe operation. One of the advantages we have, though, is that we're adding relatively little amount of weight. The Safran Honeywell system is got a target weight of 880 pounds. Our weight on the wheel is less than 100 pounds per wheel. So it's, in that case, a little bit easier, but certainly it has to be engineered for the additional weight advantage, additional weight gain, and that's a change. Our team, however, includes Endeavor Analysis, who are the leading independent gear company in the world. Their founder opened Messier America and was the 787 chief landing gear designer. So we have the expertise in-house, also the 737 DER, and engineers for Endeavour worked on the A320 gear as well. So, so we have the expertise to do the work in-house, and that's a cost that we are taking on. In the main gear, however, as I pointed out, if you're going to put another heat source next to the brakes and another fan, you're probably going to have to recertificate at least the brakes on the aircraft. That's a big deal. That's a much more expensive proposition. Yes?
Thank you very much for describing something that looks very, very good. Can you tell us about how much electrical power you're going to need from the aeroplane, please?
We are going to use the power that is available from the APU. We've done the tests on the aircraft. We know what power is available, but that information is competitive.
Just a question, please.
Yes.
Thank you. For the time saving, I noticed you mentioned from the engine start pushback to the beginning of the runway, but you mean and after the aircraft clearly leaving the runway to the gate.
Let me clarify.
Which mean approximately 15 minutes saving. You are saving 15 minutes per flight, right?
No. The time savings are all at the gate. E-taxi will not save any time in actual taxi. In fact, e-taxi may cost time.
With engine off, you are saving time for the engine life.
You're saving engine time, yes, but you're not saving the actual airline operating time. So the engine time is, and I gave those numbers, about $1.50 for maintenance and $1.54 per minute for fuel consumption. And so depending on the operation, WheelTug or any other solution is going to engineer for a different case. So we like gate operations and stop and go. Because once you're going 20 or 30 miles an hour, the runway is only a few minutes away anyway. In which case, why are you running your e-taxi? You have to start your engines.
I mean, engine life, less than fuel saving was 15 minutes.
Right, so if you're JFK for 45 minutes on the ground, because you're sitting there not moving, and you've got a moving taxi line, the fastest you're going to go is 5 miles an hour. That you would use WheelTug for.
And I don't know, you can eliminate those ground people if the airline, they install like a camera.
Initially, we would not eliminate the people. On a airline I'll give an example. I read this recently. At Heathrow Airport, at one gate, there are 20 different procedures for chalking the airplane. At one gate, depending on which airline is parked there. The number of procedures multiplies. The complexity is huge. We're talking about opening up the envelope of possibilities. So the airline at Schiphol, with a twist, they may not have nobody because Schiphol is comfortable with few people on the ground. At Reagan National, they may always require 3. This is on an airport-by-airport basis, but this is one of the reasons why we have to be involved in the process, because we want to pool the knowledge. In fact, we're going to have a conference next year where we work on entry into service, and we pool the knowledge and comfort level of the airports and the navigation services and the airlines to maximize the adoption of these time-saving routines. And nobody wants an airplane that is stuck because the engines haven't started at the end. And that's one of the issues that comes up. Questions? Yeah.
Another question, sorry. In all the maneuvering around that airport, okay, somewhere in the operation, he has to start his engines.
Yes.
Now, you showed a little cartoon up there, which didn't seem very fair to me, but that's a detail. You bring the aircraft back, you do the twist, is it? Mm-hmm. And then off you go. Mm-hmm. You showed the tug one starting his engine. Mm-hmm. Well, you'd have to start your engine at the same place.
No.
Why not?
Well, there's 2 answers to that. The first is that WheelTug doesn't stop you from rolling forward. It allows you to drive forward anyway. So you get to 5 or 10 miles an hour, and you start your engines as you go. Right. So the second part is the time savings from not having your head down while you start the engine when the aircraft isn't rolling. Instead, the captain drives the airplane with WheelTug, keeping an eye up, and the first officer can start the engine starting process.
Okay, that's what I suspected, that's what I wanted.
Okay.
Okay, fine. So he can do that anywhere.
Yes.
From the time he's away from the ramp.
He can do it. He can start his engines going backward. We provide enough torque that we overcome one engine idle thrust.
Yeah.
It's probably not a smart thing to do,
He
but
can start his engines whilst he's in the queue.
now, there's one other point.
He's got-
Yes, there's one other point I want to bring up, and it's alluded to about backing up and getting tipsy. If you're backing an aircraft up from the gate, what is the one thing the pilots are never allowed to do when the tug is pushing the airplane? Does anybody know? Hit the brakes. What happens if he touches the brakes?
Snap the key.
He snaps the nose gear, right? Can't touch the brakes. If you were driving backward by yourself and you tap the brakes, what's the worst that could happen? It tips. You get a tail strike. And it can get a tail strike very easily. You just lock the brakes and the airplane will tip back. Well, if you've got a main gear solution, you still can't use the brakes when you drive backward, but there may be cases where you've got an incline and you've got to stop the airplane when you taxi back from the gate. How do you stop the airplane in a main gear solution? You have to be able to provide forward thrust in your main gear, but make sure you don't tip. That's actually not a trivial proposition. You have to know the CG of the aircraft, you have to know the weight of the aircraft, you have to know the conditions around you. That's a problem, and in fact I heard it referred to by our competitors as a whole computer system designed to make sure the aircraft doesn't hit its tail. All right, if you've got a nose gear system braking the airplane, what happens? As you brake the aircraft in the front, it's moving backward, the aircraft will start to move a little bit up, and then the nose gear loses traction. It's a self-correcting mechanism. The system cannot do worse than lock the front wheel. We can't strike the tail. Again, it's an elegant solution without having to have a very sophisticated computer program to try to keep you from hitting your tail. Other questions? Yes?
This system for not big airplanes, so 4 or 380?
We have been asked by airlines to examine A380, A330, 787, and we may sign some customers for that, but we will not launch until a number of conditions are in place. The reason, the A330 is interesting, especially in Asia, where they operate as a short-haul carrier anyway. WheelTug saves the most money when it saves time on the ground. The A380 has a 2 or 3 or 4 hour turnaround, so it may not make any difference at all. But from an engine wear or a prestige perspective, and you know, people laugh at prestige, but why do people buy business jets? People buy business jets because it's prestigious. From a prestige perspective, sometimes e-taxi can be valuable in itself. We are focused initially on narrow-body A320 and 737. Yeah?
All right, thanks. A couple of questions. The first one is regarding the power of the electrical motor.
Mm-hmm.
And the second one is, you talked earlier about the fact that you need to reshape a little bit the nose landing gear to put your system on it. Does it include, I mean, when you said that you can change everything overnight, does it include just changing on the nose landing gear, or do you have to do it before and then just...
So there are two ways to upgrade the nose landing gear. The first is to take the gear off, take the aircraft out of service, strip the gear down, build it back up, and put it back into service. That's 2 or 3 days. The second way that's done, it would be done the same way they do nose gear work now, which is you have a rotable pool, you have an upgraded gear ready to go, you swap the gear in, and you move it down the line. So that's a rotable pool. I'll give you an example to explain how this works. In England, there was a famous scam. You have a bunch of houses in a row with one common roof, one big building, right? And somebody climbs up on the roof and takes off a tile from one roof. And he says, he knocks on the door and he says, I notice you have a tile loose. For 20 pounds, I will put a tile in for you. Okay, 20 pounds. They pay him 20 pounds. He takes the roof from the next house and he just works the whole line. That's the English like doing clever things like this. In the landing gear world, it's called a rotable pool, and you swap it the same way. So that would be 2 shifts, because it takes 2 shifts to takes 16 hours to take the gear off, put it back on, swing it, put it back into service. Did that answer the question? Yeah. Oh, the first question was about the power of the electric motor. So there's an interesting thing about electric motors, and this is a bit of a mind exercise for people. What is the efficiency of a motor that isn't moving? Anybody? 0. What was the efficiency of a motor that isn't moving and providing 1,000 pounds of torque? 0, right? Efficiency isn't the right number, and also the power consumption isn't really the right number, because the amount of power it takes to move a 200,000 pound airplane 2 miles an hour or 5 miles an hour is much, much lower than the power it takes to move that aircraft at 25 knots. So the actual power consumption challenged the APU. The APU has infinite power for low-speed operations. It's only when you're going 20 or 25 knots or faster that you start to really constrain the capabilities, because the amount of power you consume to move the airplane at a low speed isn't very high. Yes? Anybody else?
So there will be no impact on engine bleed to sort the engine since the...
No, the APUs for this aircraft, it depends on the APU, but the APUs for both of these aircraft types are rated for full bleed and full electrical load simultaneously. And by way of comparison, APU wear comes mostly from bleed. It's not really very much from electrical. If you go from 0% to 100% electrical load on an APU, your droop is only 1%. It's a very small load by comparison. Yes?
After landing, how do you start, when do you start using the WheelTug, and how do you make this change from the engines to the WheelTug?
Okay, so the answer has everything to do with how far away you are and whether there are delays. But we want the airline to always use the WheelTug around the gate. We want the airline to know that the gate area is going to be WheelTug only, because that changes the operations at the gate. But depending on how fast you're going, a lot of airlines break the rules. There are lots of airlines, they land the airplane and 2 minutes later they're at the gate and they're shutting off the engine, and the engine manufacturers scream, but they're there, right? I think somebody told me the fastest taxi aircraft, this was in the last year, was clocked, I think it was at Luton, doing 70 miles an hour on a taxiway. So, you know, if you're really in a hurry, you're not using e-taxi. But often we would expect that the one engine would be shut down within 3 minutes. Remember, the engines have a cool down period of 3 minutes. If you don't use your thrust reversers on landing, then you can turn off the engines immediately, because the flight idle counts as against your 3 minutes. But otherwise, you land the airplane, you have 3 minutes of taxi, then you can shut off your engines. By that point, you're already pretty close. You're within a couple of minutes of the terminal. You had a question? No? Yeah?
So I am a bit confused, I'm sorry. So maybe you can clarify the situation. Or certainly you can, sorry. WheelTug is mainly to be used for pushback, right? Because you said for taxi out anyway.
The purpose of WheelTug, this is where I wear my crass American hat. The purpose of WheelTug is to make money. Okay? Fuel savings are a part, engine wear is a part, time is a part. Our goal is to make money. The system will be optimized to maximize revenue. That's what it will be optimized to do. That depends on our customers, on the situation. I'm sure we will have different variants for different operators, for example. So there is no easy answer to your question. Yes?
So you will record all the expenditures the airline has on a given aircraft over some years, and you will calculate your benefit against this current cost?
Again, it is an ongoing conversation between the two. Airlines have a lot of data. They grow their data. And we will have a lot of data also. And we work it out between us. You know, there are some airlines that they came to us, they said, look, we don't like Safran Honeywell solution because it adds a lot of weight, and our taxi times are very short, so we don't want e-taxi. A lot of airlines. If you're operating in South Africa or in New Zealand, unless you're flying to Melbourne or Sydney, there's no delay. There's no reason to have e-taxi. In fact, go around the world and find any airline that uses dual-engine taxi out today, all the time, and that airline is probably not a very good candidate for e-taxi for the taxi. But gate operations, we can save everybody a lot of money, and that's a big deal. Did I answer the question?
And you will have lots of advocates or lawyers on your team?
We are in,
I think it's
I'm an American talking to an audience in France. Lawyers are a fact of life.
very subjective the business model. So how
Yes, it is negotiated. What is the price of an airplane? Can you name me the price of an airplane? I can tell you the list price of an airplane, but that is not the price of the airplane. And depending on 100 different conditions, you know, nobody knows.
everything will be
Everything will be negotiated.
negotiated and
Yes.
put down in contract and
But the defense for the airline is simple. It comes down to this always. If they don't save money, they give it back. If they save money and want to keep it, they keep it. But that is their protection. It means they're never locked in. It means that if any time they change their mind, they go away. So far, we have 11 carriers who've signed up. None have said no. And we have many more that are signing up.
And for the landing gear, you guarantee that the landing gear doesn't lose any value?
Well, there are different ways of doing this, and we're talking to numerous companies about how best to do the landing gear modifications. But the lessors would be happiest if we just replace the gear with something else, with a different landing gear. And that is possible. We have companies interested in taking that business. And then that would be part of the lease. Then when the airplane has WheelTug removed, it gets the original gear back on with all the miles still on it, good to go, and the lessor is happy he does a dance. Yes?
The A320 and the 737 just have 2 wheels per bogie.
Yes.
Will you be able to do twist and turns on the larger airplanes with 4-wheel bogies? Will that strain the undercarriage?
I don't know. The larger aircraft we have not done much work on. We have interest in E-jets, we have interest in MD-80s, we have interest in the larger ones, but we're not spending resources on them at present. That's a good question. I would point out, though, that in the nose gear, you are eliminating the side loads that you get. If you have a right engine taxi and you make a hard right turn, you can crack the strut. With the WheelTug driving in that direction, the loading on the landing gear can be much less. Yeah.
But along those similar lines, are you convinced that by introducing that on the nose gear, if you introduce this twist maneuver, you're not changing the main gear loading in a detrimental way? And for instance, when you certify the system outside, I presume, the original manufacturer's arena, that you're not introducing something that...
Well, 2 things. First of all, the thrust is much less than an engine provides. So turn should be significantly less wearing to the airplane. And lots of airlines tell their pilots don't turn sharply because of damage. WheelTug should eliminate much of that damage. But there is an exception. If the pilot locks, if the pilot locks the right gear, the right brake, differential braking, and turns right on a soft tarmac, he can dig a hole. And that can happen. They have to, in our case, they have to not lock the gear. The A320 has a stance that is more of a problem than the 737 for this particular situation. Am I convinced that we thought of everything? Of course not. If I said that, I'd be a fool.
I'm just thinking from a manufacturer's point of view, the fatigue design spectrum does not have...
We have to certificate for the safety case required by the regulators. The customers are the airlines. Yes.
So the question is, what the certification pass? Are you going to work in STC and
STC product?
What is the master schedule? When you plan for the first cert and when you plan for the first delivery?
The first cert and delivery should happen about the same time, but it won't happen before the beginning of 2015. And the reason has everything to do with the integration of the system. Most of the system is complete, but the integration is not done yet, and that relies. To be expedited relies on data access.
Which aircraft is this going to be, 737 or A320?
That depends on Airbus and Boeing. Yes.
Whom do you talk to? To FAA?
You mean for certification?
Yeah, for certification.
For certification, we are working, the FAA is primary, and we work through the bilateral agreements with EASA and worldwide. As is done with hundreds of other STC products. But of course, when you do the FAA and you expect for EASA, you have to meet special conditions also that would be set by EASA. But the FAA is our primary point of contact. Other questions?
You mentioned integration, but then earlier in the presentation you said there wasn't really an issue. What do you mean by integration?
So for example, if you have to prove that the aircraft is safe on landing for shimmy when the front wheels, because you're adding weight, then you have to provide the data that shows that the additional weight that you're adding doesn't actually negatively impact shimmy or the traction actuator or other things that are going on. And so it's not enough to build a system that works. To certificate a system, you have to prove how it breaks, and you have to prove that the way in which it works is compatible with the aircraft's design. Does that make sense? So the integration is test and analysis process in order to ensure that you don't break the aircraft, and that's the key thing. Data makes that easier to happen. Otherwise, you have to make the data yourself, which is harder. Any other questions? Yes.
Will you go even without the airframer support, or
if necessary? We have
on Boeing either on that?
we have parallel a path that is looking very promising, but we have not finalized it yet.
But how can you do that if you need to modify the landing gear structure?
An excellent question, and one I'm not going to answer. It is an interesting world, aviation. Any other questions? Yes.
When you talk about 500 or $700,000 of saving a year, it's then minus the 50% that the airline owes you, right?
Yeah, but I'm actually talking about $3 to $4 million of savings per year, and 50% of that, if we do it right. If we don't do it right, it's only $1 million, so it's half $500,000 to us and $500,000 to the airline every year per airplane. But remember, we're talking about hundreds of dollars saved per flight. Today's profitable airline makes $100 a flight. So this is a multiple of the savings that an airline gets today, just from a no-commitment upgrade to the landing gear. Yes?
Just to be sure, it's savings per year per aircraft?
That's right. The number is big. That is why that particular number here, oh, actually, I'll take it up from the top. 1 second. Magnitude. The yellow is the savings, the revenue to the airline. This is from buying a Neo Max aircraft. This is from putting on a WheelTug without the twist. This is from putting on a WheelTug with the twist. And this is the combination. Net savings per aircraft per year. That's why, even though no airframer is on board, we have 573 systems already announced. 1 out of every 22 narrow bodies flying has a WheelTug reserved today. And next week it will be more. Any other questions? Yes.
Sorry.
Yeah, there's 3 of you. It's great.
What are the black costs?
Right.
The black is how much, well, the black, in the case of the WheelTug, it's how much we get paid.
It's what?
Oh,
We get 50%.
okay. Well,
We are in the business of making money.
if you have 2 million savings per year per aircraft,
We take home $2 million per year per aircraft, and the airline takes home $2 million per year per aircraft. It's like giving a drunk 50 euro and say, go have a pint and give me 25 back. If you can trust the drunk, you're in good place. What?
I'm still not reading that. You were telling me that the savings are 2 million.
No, the savings are 4 million. Here is the top to the bottom, right? $4 million. The airline keeps half of it. We keep half of it.
for Neo Max, the savings first are led by acquisition of a Neo Max.
Well, that's a hard number to figure out because, as we know, nobody knows the price of an airplane. But in our talks with people who run leasing companies, people who run airlines, and people who used to run airlines, that's about right.
So you take $500 out of any airline buying a Neo?
No, they can do it too. It's not exclusive. There's no reason you could not do both. This is a retrofit technology.
Why do you label that costs?
Because it's the cost to the airline.
You just told me that it's
Well, okay.
to the total benefit.
The total benefit is $4 million. They get to keep half of it.
Yeah, so that 2 million in ground is the airline's benefit.
I'm very happy. I think you understand what we're trying to say.
Yeah,
And I'm very happy to concede the point that the graph does not communicate that well enough. Because if it did, you wouldn't be pushing me.
Yeah.
We're working on it. We're always trying to improve.
What's the price
Forgive
of
me.
the unit?
The price of the unit is free.
You can't have free.
What do you mean you can't have free?
Because.
What do you mean, how much does it cost us to make the unit?
Yes.
One of our suppliers is in the room, one of our partners is in the room, and I guarantee you that their profit margin on their product is going to be very good indeed. All of the WheelTug supply chain will do well. I'm not answering your question. Yes?
It seemed to me that the size of the wheels look different when you presented the...
Yes, one is fatter, but they are the same wheels, the same tires. Here's a picture close up. This is on my back porch. WheelTug on the right, normal wheel on the left. It looks bigger, but it isn't. It's the same size. It's like wearing stripes makes you look thinner, right? Apparently. Anybody else? Yes.
When's the first commercial use of WheelTug scheduled?
I said that the earliest it would be early 2015, depending on factors that are not within my control. Influence, but not control. All right, any other questions? Yes.
How many employees do you have?
0.
Only partners?
Partners and consultants. How many employees does Airbus want to grow every year? Very few. You don't want to hire people, it's sticky. But yes, we have a lot of people join us. We have hundreds of people who work on WheelTug every day. Yes?
So by early 2015, you'll have the capacity to produce it on an industrial scale.
Right, so that's the question. And that is in part dependent on the growth in our customer support organization, whether we're going to be able to ship 5 a month, a dozen a month, or 40 or 50 a month. Ideally, we'd like to match or exceed the new build rate. Because even in the backup, there are going to be, by 2020, 20,000 of these aircraft flying. That's a big backlog. So we want to make it fast. But I think the assumption would be a handful per month in the beginning, probably as many as 20 or 30 a month at the end of the first year. But it's not a big system. This is not like making an aircraft. This is a very, very, I saw the A380 FAL today. It was phenomenal, incredible. WheelTug is nothing by comparison. Yes? Somebody else? Yes?
I think it should be noted, completely separate from your presentation, your one remark, a new A320, which is going to be a worse passenger acceptance vehicle than the 757 by ratio of doors to passengers to get out at the end of the flight. I think that is worth noting very seriously.
We are well aware that turnaround time and passenger experience for lots of passengers in one door is a concern, and it's not necessarily one that everybody has thought of. The trend in the industry is to get to bigger and bigger aircraft. The 737-600 didn't sell, the A318 didn't really sell, A321 and 737-900 are selling. They're putting in more and more seats. But if you don't actually get to fly more passengers per day because it takes you longer to turn the aircraft around, the economics may not be there in the same way that people assume. Okay? Hugh wants the microphone back. It's been too long. Oh, by the way, I should point out, this is our new cockpit panel that Gables is making. It's simpler than the old one, that it's a hands-free. You just dial in the torque level, and you can see both the power and the temperature on the system. The SD card for recording data and for maintenance purposes is under this flap here, and it's a guarded reverse switch. It's a very, very simple system.
Voice actuated?
Not voice actuated, no. No. People have said, why don't you use an iPhone to drive the... No. Not in aviation. Thank you very much.